Truth Revolution.
From the biggest of the big things to the smallest of the small things and everything in between things, we bring you the universe. This is Truth Revolution.
Ooh.
And this is where faith and reason meets. I'm Pastor Dave. That's Pastor Jeff. And we are from Revolution Church in Salina, Kansas.
We bring you the universe.
We do.
I fear you're overestimating our abilities.
Well, it's not our abilities. It's the guests that we have, Jeff.
Oh,
So,
then I fear. I mean, he's smart, but can he bring the universe?
Well, he's bringing the small universe.
The small universe?
Right?
All right.
Yeah.
Hey, this is going to be a great show. You got to get to Revolution Church, but this is going to be a great show.
Yeah.
We're talking about some of the smallest things around. But actually, the last time we had this guy on, we talked about things that were smaller than these, but that's
Right.
okay. So we're a little bit bigger. Let's just get in the show. Stop making people wonder what we're talking about.
All right. Well, Fuz Rana is the Vice President of Research and Apologetics at Reasons to Believe. He is the author of several groundbreaking books, including Who Was Adam?, Creating Life in a Lab, and The Cell's Design and Dinosaur Blood and the Age of the Earth. He holds a PhD in chemistry with an emphasis in biochemistry from Ohio University.
Yes. So welcome to the show, Dr. Rana.
Jeff and Dave, hey, how's it going?
Good.
Really well. Always fun to have you back here. So we're talking today about stem cells, and this has been a debate for a long time. So before we get into the debate or issues or anything like that, let's just talk to us. What the heck are stem cells in the first place?
Yeah, well, stem cells are these special types of cells that when they are found in tissues in our body, give that tissue the capacity to regenerate. So, for example, stem cells are found in the tissues that make up our skin, blood, for example. And when those tissues wear out or when they become damaged from disease or from injury, your body can replace that damaged tissue or that lost tissue because of stem cells, which basically divide and then transform into the different cell types that are part of those tissues that are needed to support the operation of the tissues. Now, there are other tissues in our body that cannot regenerate. Usually it's muscle and nerve tissue. And the problem there is that there are not stem cells in those tissues. So if somebody, let's say, God forbid, has a spinal cord injury, that nerve tissue can't repair itself. And so there's no way to really treat somebody who would suffer from paralysis due to a spinal cord injury. But the vision is on the part of the biomedical research community is if we could find a source of stem cells to infuse in that damaged tissue, that those cells could maybe repair and replace that lost tissue and return some of the function or maybe all of the function. And so there's a vision that stem cells could provide this what's called replacement therapies, cell and tissue replacement therapies that could literally transform medicine, not only helping people with spinal cord injuries, but helping people to more fully recover from stroke, from heart attacks, helping people that suffer from neurodegenerative and muscular degenerative disorders. So it's a very exciting, very promising area of medicine that hinges on and centers around these really special types of cells called stem cells.
Wow.
That is interesting.
Okay, so I'm actually just thinking about the last time you were here talking about nanotechnology and biomolecular machines and going, what if the machines and the stem cell, and this is I'm not a scientist, but I'm just like, this seems like something could happen there.
Right. Sounds good, right?
Yeah.
Yeah.
I don't know. Is that possible?
Well, it is. I mean, in a sense, as what we're going to learn about today is that people are beginning to marry some of these technologies that would be at a nano scale with technologies used to as a source of producing stem cells. And so we're really seeing a marrying of what's happening at a biochemical level with what's happening at a cellular level in terms of technology development. So it is indeed possible.
Okay, man, 2018, man. Right. We got brand new stem cell research. We got nanotechnology. We got new flavor of Doritos. Like, there's just like, no end to what we can do.
Yeah,
this is
awesome.
This is amazing stuff. All right, tell us a little bit. You kind of mentioned new technology, where it's kind of going. What's some of the newest research? Because I actually saw you guys post this information. You posted on Facebook about this physics article from phys.org. Tell us a little bit more about where this is going.
Yeah. Well, I mean, one of the sources of stem cells that people are attracted to in the scientific community, and this has been the case for about 25 years or so now, is embryonic stem cells.
Right.
These are cells that essentially exist in the very early stages of embryonic development. And these cells have the potential to develop into any of the 210 different cell types that are part of the human body. And so the scientific community says, well, these would be an excellent source of stem cells that we could use for cell replacement therapy, where we would inject either embryonic stem cells, in this case, into the spinal cord, or maybe cells derived from those embryonic stem cells. The problem with this course of action is that you have to create in a laboratory embryos, and then you have to destroy them in the very early stages to get embryonic stem cells. And so this is where a lot of controversy, for obvious reasons, arises, is because for people like us, we view embryos as being human beings. Mm-hmm. And so you are creating a human life to destroy a human life. And so a number of years ago, I was very heavily involved in this debate about embryonic stem cell research. And at that time, one of the things that we were advocating is the search for alternative sources of stem cells that could be used for cell replacement therapy that wouldn't involve human embryos in any way, shape, or form. And this is where this new technology that is coming into play that's so exciting. And it actually stems back to about 2007, 2008, when a team of researchers discovered that they could take a skin cell called a fibroblast and convert it into what they called an induced pluripotent stem cell. And that's a mouthful, I know, but it's essentially a cell that behaves just like an embryonic stem cell, but it's essentially derived from a skin cell. So no embryos are involved. These are cells coming from adult tissue. And this was considered to be a huge breakthrough, because could these induced pluripotent stem cells be the source of cells for replacement therapy as opposed to human embryos? But the problem is there's a downside, and that is the process of this transformation is highly inefficient. About 0.1% of the cells actually transform. And the procedure that you have to use to transform the cells can render those cells tumorigenic, meaning that they are likely to form tumors when you implant them in tissues, which isn't a good thing. And there's also other things that they were concerned about related to how well did you actually reprogram the cell? Did it fully get reprogrammed or only partially reprogrammed? And so these were technical concerns that kind of dampened the promise of induced pluripotent stem cells.
Okay, when it actually works, and it's not a potential for a tumor or things like that. Let's just say when it actually does what it's supposed to do, does it actually have the same viability and possibilities as an embryonic stem cell, or are there still limitations there?
The answer is yes, it does have the same possibility, and people have shown that they can take induced pluripotent stem cells and get them to develop into different cell types that could be ideally useful for again, cell and tissue replacement therapies. So that potential is really there. And, I think it's also important to recognize that while everybody sees a lot of potential for embryonic stem cells, they too have a host of technical issues associated with them that may frustrate their use in a clinical setting. Rejection is one of them, because the source of embryonic stem cells would not be the patient that needs that replacement therapy. And because of that, it would be the same issue as that happens during organ transplant procedures, where that the donor can actually reject the organ. The same thing would be true potentially with embryonic stem cells, is that there could be those rejection issues. And then on top of that, you also have tumor genicity, tumor forming events that frustrate embryonic stem cell utilization as well. So it's not like embryonic stem cells are ideal, but many people in the scientific community view them as the preferred choice for stem cells. But again, induced pluripotent stem cells are really intriguing, and the potential of using them is very real and is very exciting.
So the induced pluripotent stem cells are actually taken from, if I had a spinal injury, you would actually take some of my stem cells and use those to help fix my own body.
That's exactly right. In fact, it wouldn't even be your own stem cells. It would just be
my own skin cells.
Your skin cells.
Yeah. Wow.
So,
that's right.
And that completely avoids the whole issue of rejection.
Yeah.
It completely eliminates that particular issue. So, there's as a Christian, I would argue, let's devote all our effort in dollars into trying to get induced pluripotent stem cells to work, and let's set embryonic stem cells on the shelf and not pursue that line of research, because one possibility has no ethical and moral issues associated with it, whereas embryonic stem cells are just, littered with ethical and moral quandaries. So that would be my call as a Christian, is let's go down a path that doesn't have that moral and ethical baggage associated with it.
A lot of the places that push embryonic stem cell research, is it their stance that just embryos just aren't people, or is it they're kind of agnostic to that? We don't know, but it's really good research, or what do a lot of them say?
I think there's a lot of the people that are advocating embryonic stem cell research are probably not people in general of faith, or people who take a view of the embryo as being a human but not a person. You get into very complex debates as to what really makes a human being a human being. And so they view these embryos as really being, again, non-human. And of course, if you take let's say a materialistic or a naturalistic worldview where human beings are just the product of evolution and we're just basically biological machines, there's nothing special about us. Well, if that embryo is just a few cells in size, it doesn't have a self-awareness, it doesn't have sentience, so why not take it and use it to alleviate the pain and the suffering of another human being? So many people that advocate embryonic stem cell research, ironically, really do want to treat people. They want to alleviate pain and suffering. They have a high view of human life in that sense. But the irony is they're willing to sacrifice a human embryo, which, again, many people think of as being a human being, and in order to alleviate the pain and suffering of another person. And this, to me, is where the Christian worldview has so much power, because the Christian worldview would have the mindset to promote science and technology. It's part of the dominion that God has granted us as image bearers. We want to alleviate human suffering. We want to promote human flourishing. We want to love our neighbors because people bear God's image. But because people bear God's image, we also are willing to put in place kind of boundaries that we won't cross. And those boundaries are related to the dignity and the sanctity and the value of human life. So I think the Christian worldview is a very robust worldview, maybe the most robust worldview when it comes to guiding, biotechnology development. And so we have to be able, as Christians, I think, to articulate the power of the Christian worldview, but also to point out that we are concerned about people that are suffering, but that there's other alternatives that are in play, and let's pursue those alternatives so we can all have a win-win.
Man, that is so good. I mean, for even since the early Christianity spread in part because the ancient Roman Empire would do things like, if they didn't want a child, it wasn't abortion. They would expose the child. They would take them out, put them on a hill, say, we're going to let this child die. Christians would actually go and take the children and raise them as their own instead of allowing these children to die. That's one of the reasons Christianity spread in the early Roman Empire. And like right now, actually, I was in a meeting in the state of Kansas with some high-level officials about doing foster care and things like that. Someone said, we need to promote this more in churches. And someone said, well, is that a separation of church and state issue? And someone else said, we all know where foster parents come from, and they come from churches.
Amen.
And so, someone who has this argument, well, if you don't like abortion, then you should be doing adoption. You're not doing that. Well, the Christians are.
Right.
We are doing that sort of stuff. Hey, we're going to be right back on the other side of this break.
Truth Revolution. And we're back talking about stem cell advancements. We're here with Fuz Rana from Reasons to Believe.
That's right.
And we're talking about some really good stuff today.
Yeah, so, Fuz, we were talking about these different types of stem cells, and we talked about gene editing early on, and let's just get in a little bit about how this works, okay? Let's marry the pluripotent stem cells with gene editing. I can't even say the words with gene editing and pluripotent awesome cells. What happens here? Let's talk about a little bit about putting these technologies together.
Yeah, well, this is an exciting breakthrough that just happened, at least it was reported just a few weeks ago, when a team of researchers figured out that they could use the CRISPR-Cas9 gene editing technique, which is a very powerful new gene editing technique, to actually facilitate the transformation of fibroblasts into these induced pluripotent stem cells. And the efficiency of the process and the crispness of the process has dramatically improved. And through that process, the researchers also have a better understanding of what's happening during the reprogramming. And this is moving us even closer to helping to resolve some of the issues with induced pluripotent stem cells that are hindering their migration into a clinical setting.
Okay, so and just to be clear with people, CRISPR is a tool that manipulates genomes, right? So you can actually target particular things in DNA and alter them. Is that right?
That's right. And what they're using the CRISPR-Cas9 technology to do is find that those one or two switches in the genome of the fibroblasts, that when they hit those switches, boom, it turns that cell into an induced pluripotent stem cell. So they've actually found those two or three switches that will actually do that transformation, so they can be very targeted in what they do. And one of the things that's really cool, nobody's done this yet, but the potential is now there, is let's say you have a neurodegenerative disorder. Well, there's no sense in taking a fibroblast from your skin and converting it into an induced pluripotent stem cell and implanting it into the nerve tissue that's degenerating, because that same genetic defect is in your skin cell.
Right.
And it would be in the induced pluripotent stem cell as well. But if you could now couple this transformation with precise gene editing that could repair that genetic defect that's causing the neurodegenerative disorder, you now have even ratcheted up the possibilities one step further, where this could actually be a genuine bona fide treatment of that individual suffering from that genetic disorder. We're still, away from doing that, but this new advance is even opening up that possibility. And so the possibilities are even more exciting than even what this discovery actually indicates.
I can only imagine. I mean, we've got friends with MS and things like that. And so we're on the road to literally taking someone's cells, going in saying, hey, let's turn off the disease,
right,
and then put these back in, and then their body repairs itself.
It's like you take somebody to a garage. Hey man, something's running a little off. Can you do a diagnostics? Let's try and fix this. And they do. And I'm really amazed, because I just thought the CRISPR was a drawer in my refrigerator. So who knew? It's also that, which is also good, because it has vegetables in there. Do you eat vegetables? Sadly, no. I don't even know what the inside of a CRISPR drawer looks like.
That's okay, Dave, because there are some cures coming up for people like you.
Right on.
That's what I hear. Now, okay, let's just talk a little bit about how this study got started. Why did scientists start studying how do you turn skin cells into stem cells? How did we even get there?
Well, as I mentioned early on, there's a lot of people in the biomedical community are just enamored with embryonic stem cells, and that would be their choice to develop this cell and tissue replacement therapy. But there were scientists who weren't necessarily believers, who were hearing the voice of pro-life people, of evangelical and conservative Christians, people of faith, who were condemning embryonic stem cell research, and that motivated them to see if there were alternative possibilities. And that's where the motivation for pursuing induced pluripotent stem cells came from, in part. And so this is an example where the Christian voice has actually shaped the direction that the scientific community is taking, at least part of the community is taking, in terms of developing biotechnology. While they may not agree with Christians, they hear that voice, they hear that concern, and that has motivated them to try to find more ethical and morally appropriate solutions to very real problems. And so the encouragement that I would give to Christians is, let your voice be heard. Don't hesitate to speak up. Do it with gentleness and respect. Do it with sensitivity. Try to build bridges, not make enemies in the process. But yet at the same time, let's be engaged with our culture. Let's be that salt and that light. And you might be surprised at the changes that you can affect when what you're doing is done out of genuine love, where you're trying to be part of the solution, not just simply a voice of condemnation. So it's important for us to raise our concerns, but let's do it in a way that people see us as allies, and our voice can shape what happens with technology in a way that everybody wins. And that is, I think, a way that makes the Christian faith appealing and will introduce people, I think, to an openness to hearing the gospel message.
That's awesome.
That's great. I mean, it just brings to mind Jesus saying, you are the salt of the earth, right? We are a preserving factor. We bring good flavor. All these things that Christians do when we do life the way the Holy Spirit directs us to. And I like what you said about doing this with gentleness and respect, right? Our job isn't to come in with AK-47s and say, listen up, people, right? Our job is to come in to represent Jesus.
Amen.
I mean, Jesus even said, love your enemies. So even when we disagree with people, we're approaching them with love. Even when we think they're doing things that are awful, we're coming at this with love. And man, Christians are obviously, as I mentioned, having a huge effect in the adoption and foster care world. Christians are now having, as you mentioned, a huge effect in the scientific world. And if we can keep this sort of positive moral pushing, I think we can make a lot of great differences in the world that aren't just political, that actually change people's hearts. I love that. Hey, well, why don't we go ahead?
No, I was just going to say, it's just really important to keep in mind that a lot of people that advocate embryonic stem cell research are not necessarily moral monsters. They really are motivated by trying to see people with diseases and debilitating injuries treated. And so that's a bridge point. And if we keep that in mind, we can, and we treat them as again, allies, not enemies, I think we can have a bigger impact than we even have now.
That's great. All right, we got a little time left. Let's go ahead and do Bible contradiction.
Bible contradiction.
All right. Check this out. Does God or does he not enjoy a sinner's downfall?
Okay.
Like, is he up there laughing at people, Proverbs 1:26 says, I also will laugh at your calamity. I will mock when your fear cometh.
Okay.
Ezekiel 18:32, however, says, I take no delight in the death of anyone, declares the sovereign Lord. Repent and live.
So does God laugh like it says in Proverbs, or does he not laugh in Ezekiel? Well, this is, our cracked acronym, the C for context. This isn't God talking in the book of Proverbs per se. Right. Proverbs 1:20, so just 6 verses before, where it says that I laugh at your calamity, it says, wisdom calls out in the streets, she shouts loudly in the plazas, and then the rest of this chapter, and indeed a lot of the rest of the book, is wisdom talking. Okay, wisdom has been personified as a lady, and she's calling out to you, and she's saying, hey, it actually says, if you look a few verses later, it says, if only you'll respond to my rebuke. But then, because you neglected all my advice and did not comply with my rebuke, so I myself will laugh when disaster strikes. Okay, this is talking about wise versus unwise decisions. That's why when you reject wisdom and your life gets ruined, it's your own fault, right? That's all this is saying. This isn't saying that God is laughing at you. This is saying wisdom is laughing, meaning the personified idea of wisdom is saying, don't put this on me.
Right.
You rejected me. This disaster is all you.
Right.
Hey, Dr. Ron, is there anything you would add to that?
I wouldn't, and one of my favorite things when I come on your show is to listen to you guys do Bible difficulties. So I get a lot out of it.
Awesome.
Just sitting here listening to you guys. Great job.
That's cool. All right, so that's the answer for our contradiction today.
Bible contradiction.
All right. They set him up. We turn him down.
With love.
With love, right.
All right. So let's get back to the stem cell thing here. We got about 2.5 minutes left. What would you say is the most critical issue moving forward, just for us, the general public, Christians? How can we kind of bring this to light? What do we talk about when we're talking with people? Where do we go from here?
Yeah, I think it's really important to let people know that we are aware that there are genuine alternatives to the use of embryonic stem cells to treat these, again, diseases and injuries that are so devastating to people. And again, to really muster a strong sense of compassion for people that do suffer from those disorders. But if we could become advocates for promoting and investing dollars into certain areas of stem cell research, I think we would be viewed as a positive force, as a positive influence. Wouldn't it be great if there were Christians who engaged in fundraising activities to specifically fund research on induced pluripotent stem cells or adult stem cells instead of embryonic stem cells? That kind of thing can make a big impact. So I think as Christians, we need to think big. And how can we even go one step further and influence our culture? And there's nothing like putting your money where your mouth is.
Amen.
That is so good. All right, we're gonna encourage everyone to do that, and maybe if we'll find some organizations that think scientifically, like Reasons to Believe. We're going to put them on our website and consider donating there, because it actually does make a difference. Makes a huge difference. So, hey, thanks for being on the show again today, Fuz. Really appreciate you, man.
Jeff and Dave, thanks for having me. It's always a blast.
Yeah, this has been great. So, Dave, where should they go right now?
TruthRevolution.tv.
That's right. If you want to get over Reasons to Believe, that's reasons.org. Lots of great resources. You should be on their website every day.
Right.
I know I'm reading something from them almost every day. So, in the meantime, coming out to Revolution Church, we'd love to have you. It's not boring. It is interesting.